And we are live. It's always exciting to start these live podcasts because there's no turning back. Once you start the on button. This is it. So, Jon Green, thank you very much for joining. Really appreciate that. It's a beautiful day on April 20th, and it's noontime Eastern time. And I have the great pleasure to introduce Jon Green, who's a VP and Chief Security Technologist at Aruba, a Hewlett Packard enterprise company. And you have a really fascinating background. You started as a product manager a while back, and then you advanced. You took over more and more responsibilities to where you are today. So why don't we get started and just give us a quick overview of your role today and responsibilities, and why you don't really like the word cyber.
Yeah, I've spent 18 years at Aruba now, which is a long time. I'd never spent that much time in a company before, but really like the culture and the company and the products, and they keep giving me new challenges to go after. So I kind of fell into security. I've always been interested in that area, and these days, it's hard to find cybersecurity people. So I've got all kinds of stuff. I've got an internal threat research team, and their job is to break our products before anybody else finds those problems and hopefully get those sorts of things fixed. I've got the product security incident response team. I've got kind of an internal security governance in terms of building secure products and making sure the development teams are doing the right thing on that front. And then I've got the trust and assurance team, and they handle things like federal certifications like FIPS 140 and common criteria. And then, overall, I just try to help the company look after what is our security roadmap, where do we fit within the security landscape, where do we not fit, and then do a lot of talking to customers. So that's it in a nutshell.
And it's amazing. I mean, wireless wasn't even a thing when you started. I mean, it's we've had so many iteration of the different protocols of wireless and the security controls over that. How did wireless look like when you just joined Aruba back in the day?
Yeah, Aruba got started as a Wi-Fi company, looking after enterprise-grade Wi-Fi. And back in those days, this is 2002, 2003, web encryption had just been broken. And so the adoption rate of enterprise Wi-Fi was actually negative at that point. People were pulling Wi-Fi back out of their corporate environments because they didn't trust the security. And that really caused, as Aruba got started, that caused us to over-rotate on security a lot. We built in a lot of additional security capabilities because those customers needed to be convinced that they were in good hands and that things were safe. So, rapidly, right around that time we started, the predominant method of secure Wi-Fi access was either an open network or web encryption. And then you ran a VPN tunnel, you ran IPsec over the top of that. And some people still deploy that way today, but soon after that, WPA came out, and then it was WPA2. And of course, today we're here with WPA3. And those are pretty good security protocols. I mean, we've got lots and lots of government networks, in the Defense Department and so on, that are deploying Wi-Fi networks using WPA2. So it's a fairly well understood and trusted technology today.
Yeah, it's pretty amazing. And, there was 2G back in the day, 3G and 4G, 5G now. And what's amazing is now you have a senior role, but you still, like, just from looking at your background, you still have the hands-on experience with a bunch of boxes in there. I think I asked you last time we had a conversation whether Aruba pays your power bill, because it seems like you got a lot of equipment in the back. How do you keep abreast of all the nuances, the new protocols, and keep yourself kind of a hands-on still, despite the fact that you oversee a lot of different areas within Aruba?
A lot of it's honestly just listening. If I go talk with customers and they're bringing up topics and I'm hearing those same topics over and over, or if I'm talking to our engineering team and they're bringing things up and I don't know what they're talking about, that's my signal that I need to go and figure something out. And so I can't afford to be a deep expert on every single topic out there, but I need to know at least, I need to have the vocabulary. And I think everybody that works in this space does, so that, if somebody talks about cloud computing, and that's kind of one of the big areas that I'm focusing on right now and trying to learn more about that area. We got to have that working vocabulary so that we know kind of what we're talking about. So really it's just listening to what people are discussing and then saying, do I know enough about that? No, I don't. I need to go and start doing some reading or watching YouTube videos or whatever it is.
Yeah, absolutely. I'm very big on YouTube videos. There's so much out there. There's so much information. There's almost no excuse to not be able to stay on top of things. So, our topic today is I wanted to touch upon zero trust and then a bit about how it relates to us going back to work. You know, some of us got the vaccines. It seems like we're moving into a hybrid model where people are spending, a few days a week office and then doing a lot of, remote work and so on, which is, I think, is here to stay.
Mm-hmm.
Why don't we start with a question, kind of general question, what kind of definition exists for, for zero trust? And maybe you can jump from there.
Yeah, this is a challenging one just because any company you talk to, any analyst you talk to, I think has their own definition of what zero trust means these days. And that can be confusing. You've got companies abusing it by sort of slapping that zero trust label on anything to do with security. And we need to be careful on that. Gartner points out, zero trust is a modifier. It doesn't make sense unless you put a noun after it. And so zero trust networking or zero trust networks was sort of the original concept there. Yep, you got a good slide there for it. My definition broadly is just because you can connect to a particular network or you are connected to a particular network, that doesn't give you any sort of special access rights to data or to applications that are on that network. So let me give you the anti-zero trust model. If I think back to Aruba's early days, our internal network, it was 10.x, the IP address space. We had VPN access to get back into it. And if you were on that network, you had access to our bug database. You had read access minimally, but in the early days, you had write access too. And that was it. That was the only thing required to see that information was to be connected to that network. That is not a zero trust model. That's saying, essentially, the network is fully trusted, and in that world, if a bad guy gets on your network or bad software controlled by a bad guy, it's game over. They can exfiltrate all that data. They can kind of do whatever they want. A zero trust mentality says, just because I can be on a network, that doesn't get me anything. Every application, every sort of data access is going to ask me for authentication, and that's the starting point. Authentication. You can go much further beyond that in terms of how much trust I'm going to apply to that particular user. We look at it at Aruba because we're a networking vendor. We look at it a little bit differently. Just because you can plug into an Ethernet port or just because you can connect to a Wi-Fi network, that also doesn't give you full access to a network. That still needs to be based on identity, based on role, based on what you should be allowed to do on that network. And that gets especially important when it comes to things like IoT devices getting hooked up to a network.
And, the whole concept of identity and what identity is has changed as well, because, we use devices now interchangeable between the personal device and corporate device, whether it's the mobile device. How do you define that identity in kind of today's terms? And then, how does the kind of the cloud migration or cloud application change the way we access it? And how do you then control or apply that zero model trust to the cloud applications?
Yeah, identity is the cornerstone for anything you're going to do within a zero trust mentality or a zero trust architecture. Without that, it's very difficult to do anything else. Now, identity can be, at its root, identity is who are you or what are you? And what follows very closely from that is a role or authorization of what is it that you should be allowed to do. We've had this idea of role-based access control in our network systems for a very long time. That was one of the fundamental concepts when we created Aruba as a Wi-Fi vendor. And a lot of people didn't use it. A lot of people used that firewall and they said, well, permit all if you're an authenticated, employee role. Mm-hmm. And that's because with users, it's tough to figure out, it's sort of getting into application whitelisting on the network and that sort of thing. And that never really took off just because it's really difficult to do. So we might have really solid identity around that user. It could be a certificate, it could be two-factor authentication, it might just be username, password, but we have good authentication protocols for getting what that identity is and being able to trust it. Today, for the last 5-10 years, we've seen this influx of things onto a network. We would say IoT, the Internet of Things. Those have a much greater need to control access in the network itself. So I'm hooking up a television screen to a network, for example, in a conference room. I don't want that TV screen to have full access to my internal network. I don't want it talking to my ERP system, for example, but it needs to have a certain amount of access so that it can be used for the purpose it was intended. And maybe it needs internet access. But that concept of identity is much less solid with those sorts of devices. Now it depends. You've got printers, for example, that are built for enterprise use, and they might support full 802.1x authentication on the wired and wireless side. They might have a certificate assigned to them with a private key that's well protected, all these sorts of concepts. But most of the time, it's not going to be that way. If anything, they connect to a Wi-Fi network with a pre-shared key, or they're just plugging into a wired network and there's no form of authentication there at all. And now I've got to rely on things like MAC addresses, and MAC addresses are not strong identifier tokens. It's sort
easily
of
spoofed.
They're very easy to spoof. But if I have nothing else, that's what I'm going to use. And I'm going to say, all right, that MAC address is supposed to be a printer. Let's make sure that it only does printer things on the network. So that starts to get into authorization. So that concept of identity is very broad in terms of if you're talking about people or if you're talking about devices, and then what is the device category that you're getting into.
Yeah, and we've seen what was the case of the I think it was a fish tank that was on the network, and the company got breached because of that.
That was a casino.
Yeah, it's really remarkable. I mean, is there any devices do we buy today that are not Wi-Fi enabled? I think my my can opener has Wi-Fi built in. I mean, it's almost like now it's like a de facto that you buy a device and it has Wi-Fi enabled to it, especially on the enterprise side, right?
Yeah, that we're seeing. I'm trying hard to think of something that doesn't have a Wi-Fi interface. So there's a lot of stuff that doesn't have wired interface anymore, but almost everything comes with Wi-Fi at a minimum.
Yeah, and then I believe that some of these devices are, they use like almost like legacy, 2.4, gigahertz, protocols, because just to reduce the cost of running the device and manufacturing the device. They don't use the latest and the greatest, and encryption is just something that's non-existent as well on these devices, most of these devices anyway. So what's the kind of the biggest misconceptions about zero trust these days?
I think a lot of people look at zero trust and say, well, that's the silver bullet, and that's the thing that's going to solve all my security problems. Zero trust, again, zero trust networking, adding that noun at the end of it, is basically solving one set of problems, which is, do I trust my internal network, or do I trust an insider, if you will? But it's simply solving an identity and an authorization problem. If I have malicious software running on an endpoint on a laptop, for example, and that laptop, the device plus the user authenticate with a really good authentication protocol and a certificate and mutually authenticated TLS and so on, and then that device is running malware and decides to exfiltrate data, I still have the same problem that I had before. In fact, I might have made it worse, because now everything's going to be encrypted, and so sort of middle boxes that I might have for security aren't going to see that that traffic. So it's not saying zero trust everything. It's saying we don't trust the network. I still have to worry about, I can't trust nothing, right? Or nothing gets done. And so I still have some of the same old problems that I had before. So a lot of people have this misconception that zero trust means I get rid of my security perimeter. And once I've had people say, well, I don't need network access control anymore. I'm just going to treat my internal network as a public internet hotspot, because that's what zero trust means. And that's close. It's the right words, but it's the wrong interpretation. It says you shouldn't trust your internal network any more than you trust a public internet hotspot. It doesn't mean turn it into a public internet hotspot. It doesn't mean tear down the perimeter. It just means don't necessarily assume that only good guys are on the inside of that perimeter and everything bad is on the outside. So we still have to do lots of other security things that we've always done: firewall and IDS IPS to an extent, and data leakage prevention and these sorts of things.
Yeah, it's really interesting because as you mentioned, the way you describe it, it's not converting everything into like public hotspot and not trusting anything. It's just the dealing with it is very, very different, especially from the enterprise side. Are there any problems that we can't solve using zero trust?
Well, and this gets into kind of what is your definition of zero trust. So the original concept of it was very much kind of web application focused and saying, to think about Office 365. It's attached to the public internet. All the users come in through the public internet. So naturally, it needs to embrace kind of a zero trust network approach. It can't trust the network because the network is the internet. And that solves one set of problems. It solves an identity and an authorization problem. If we then continue that thinking about what zero trust is to an internal network, and again, getting back into things like IoT devices or bring your own device or guest networks or these sorts of things, those systems don't participate in that type of a framework. I might not have credentials. I might just need, internet access, or think about that television screen on the wall. It's not really playing with a cloud hosted application that it needs to provide identity credentials to. It just needs to be on the network and sitting there listening for, my laptop coming in and trying to share a presentation up to the screen. So I think if we narrow our concept of what zero trust is to just that original definition, we're missing that whole other piece of what's going on there at the network level. And that's where more traditional network access control, and when we talk about zero trust for networks and zero trust for applications, and I think you need both of those, or you're missing that whole segment of the devices and the users.
It's really interesting because I'm assuming that you, as you mentioned, you talk to customers every day and prospective customers. And when you come in and do the kind of discovery call, what questions do you typically ask? And how do you kind of match the kind of capabilities for Aruba with their business requirements? Because everything is driven by a business requirement, right? So, how do you align, kind of the want to be secure and potentially deploy zero trust network with the business requirements, and how do you uncover this and then kind of the initial conversations you have with clients?
The starting point is really, if you think about the NIST cybersecurity framework, the first step in there, or the first function in that, is called identify. And I ask people, do you know what's on your network? Do you know what's on it right now at this moment? And a lot of people will say, if they're honest, they say, we really have no idea what's on our network because it's not under the control of IT anymore. It's sort of, we've deployed the network, it's a utility, and everybody hooks up to that because it's there, which is in a way a good thing. But you've got facilities departments putting things on there now, and you think about Target stores and how they got hacked several years ago. That was through an HVAC control system that was plugged into a network, and I don't know that IT knew that it was out there. So that's kind of step number one, is figuring out what's out there. And we'll have others that'll say, well, no, we have a really good idea what's on our network. We've got a good spreadsheet, or we've got IPAM, or we've got whatever systems keeping track of things. When we go and profile those networks and try to figure out what is out there, very often there's 30% more devices on the network than what that customer thought that they had. So getting a handle on that, of what's out there, what are those things? And then the next step of that is, well, what should those things be doing? Are they, and from that follows, are they doing the things that we expect them to do? These are all kind of basic building blocks of network security. The second big step is, do you have some form of identity, some form of way to keep track of what those things are? Have you rolled out PKI so that you can use certificates? Have you rolled out some kind of, do you have Active Directory? And so users are in that, and computer accounts are in that. So getting into sort of, how are you going to authenticate devices? We can turn on authentication protocols really easily from a Wi-Fi perspective or from a wired perspective, but we need that backend database to match it up to. And different people are in different places in terms of having those kinds of identity stores. So I'd say that's where we get started.
And from looking at some past presentations you posted, you mentioned there is a gap between the resources and the education and enforcement, basically. And I'll share, this slide here with the audience. Basically, the kind of trust platform is in the middle, and then you have all the different components associated with it all around. how do you, first of all, what is that gap? Kind of can you explain that? And then how do you actually solve it?
Yeah, so this slide was actually me poking fun a little bit at another vendor that is, I think, abusing that label of zero trust, because
Right.
anybody can look at this and say that's a zone-based firewall, and they've sort of relabeled it and called it zero trust segmentation platform. What does that mean? That's a firewall. And the gap that I'm referring to there is just that the enforcement point is way too far away from the resources. So that it showed this campus zone. There could be thousands of devices in that campus zone. There's some kind of an application zone. There could be thousands of services living in that. And if that firewall is the only thing providing separation there, it doesn't really know anything about what's happening inside that campus zone. It only sees the traffic that comes to it. So if I've got, say, wormable malware spreading within my campus zone, my campus network, I'm going to end up the situation we described earlier with valid, authorized, authenticated users, but with potentially malicious software running in there. And I've got this, I'm back to square one. I've got the same problem that I would have had if I didn't have this zero trust idea. So we're big fans of pushing enforcement down to as far out to the edge as possible, and saying that first hop, that first network node that an end user or an end device connects to, that needs to have some type of an enforcement function, even if that's just VLAN segmentation. So I look at, we just deployed the entire wired network for the Pentagon, local to me anyway. They've deployed that in such a way that ports are colorless. The port is in sort of a neutral configuration. Depending on what you plug into it, you're going to get authenticated and you're going to be put into a different VLAN. And it's a very simple, it's a long-standing form of doing segmentation in the access layer network. That's kind of a minimal step that we think needs to be done. If you can get, say our Wi-Fi infrastructure, and you've got full layer 4 to 7 firewall capability there at that first hop, definitely use something like that. But minimally, you need to have some type of VLAN segmentation, so you've got users and devices that are kept separate.
And you mentioned specifically inventory is super important, right? To see what's on your network. Mm-hmm. How do you then define, from all the different devices, it can be a million type of devices, like, how do you then classify those and are able to what those are? I mean, it's almost like a very heavy lifting by itself. How do you do that today?
Yeah, this is where the world of machine learning has really advanced and is really helping us out. I don't think 5 years ago we could be talking about it in the way that we are today, but the state of the art today and we've got a product there called ClearPass Device Insight. There's a bunch of different products out on the market that are doing this, and some of them will focus more heavily in certain verticals than others. So we see, in the healthcare world, healthcare is really populated by a lot of different devices and different device types, and a lot of them are medical devices that you just gotta try to recognize those. So you'll find vendors that will focus just in the healthcare industry and say, I'm going to identify all your X-ray machines and things like that. Ours is a little more broadly sort of general enterprise focused, so not looking at any one market in particular. Broadly, what we're doing there is looking at network traffic and looking at traffic flows, and not necessarily seeing what's inside the traffic, because a lot of times it's encrypted, but looking at, in the machine learning world, what we call a feature. A feature might be what time of day does this thing access the network? What are the byte patterns going across the network? What type of DNS queries does it do? Which protocols and which port numbers is it communicating on? These are all kind of metadata about the network communication. And feeding that into machine learning models can allow that system to classify and to cluster and to say, I may not know what it is, but there's 6 devices on the network that are all the same thing. And so here's that cluster. It's cluster number 1. We don't yet know what it is, but we know that it's the same thing. The next step of that is to go through, kind of another phase of machine learning and say, does this look like something that we have seen before? That's always going to be probabilistic, right? Because any of this is kind of based on heuristics of looking at metadata and that sort of thing. And so we might come back and say, well, 80% of our customers have identified this as an irrigation controller, and 20% have identified this as a thermostat. What does it look like in your environment? And here's some hints that we can give you to that. Because we host that in the cloud, we can actually apply sort of crowdsourcing for that. So once one customer or one set of customers identifies that type of device, that information is then available in the database for the next customer that comes along and sees the same type of device. And so that type of model reinforces itself over time and lets us try to figure out, with pretty good accuracy, what's out there on the network. The side effect of that, of building that database, is we've got a record of what those devices are doing. And so that's available to the administrator to look at and say, well, show me this device that I've now classified as a television screen. Who does it talk to, and with what ports and what protocols and that sort of thing. And that can feed in later steps to say, I actually want to enforce that. I want to make sure that the TV screen is only doing those things. Or maybe I don't like certain things it's doing. I have a TV in my house here that talks to Russia. I don't know why. It phones home to South Korea, which you sort of expect given the manufacturer, but it also phones home to some server that's identified as Russian, and I have no idea why it does that. So maybe I don't want to allow it to do that because that's kind of a sketchy operation. So that's kind of that's how you get a handle on that sort of thing. And again, I think 5 years ago, it would have been much more challenging, but the state of machine learning has advanced so much that, we have good clustering algorithms. We've got that plus cloud, and allowing us to build these crowdsourced databases gives us those tools that people can use to really identify and classify.
Yeah, and it's pretty amazing because some of it is just strictly looking at standard deviation, right? You look at typically what these devices do, and if they deviate from the norm even by 20%, you flag it, and then you can compare it with your other hundreds of customers and to see what they're seeing as well in their environment. You're estimated, how many devices have you seen so far? And just I know it's kind of a tackle question, but in general, like how many types of devices have you classified so far?
I think the last time I saw it, it was somewhere between 500,000 to 1.5 million. I've forgotten the exact number, but it's a lot. And some of those are likely the same device type, but running different firmware versions, for example. So you'll see slight differences in those sorts of things. But yeah, I think it's over 1 million at this point anyway, in terms of unique device types that are out there.
That's incredible. So let's talk a bit about the elephant in the room, which is the authentication piece, right? How do you then take those 500,000 devices, and do you then classify them? Once you classify them, how do you then make sure that there's no invisible connection to the networks?
Yeah.
And do that in real time, because again, I think the risk here is for business is to block some devices that are, legitimate on the network, and then you get, this people yelling and screaming that there's no access.
Yeah, that's a tough. We see people often take a year or more to get this authentication phase right, where they're putting it in kind of a soft enforcement mode. So I'm not going to fail authentication. I'm going to allow it, but maybe give you some more restricted rights. Authentication, and I know the slide deck you've seen, I put a star after the word authentication because I kind of mean use the best thing that you have available. It doesn't necessarily have to be very secure. Something is better than nothing. So you might, and we touched on this already today, but you might have a Wi-Fi device, a tablet or a laptop running Windows 10, and it's got the latest and greatest ETLS authentication for Wi-Fi, and I've got certificates and I've got mutual PKI in place there. That's really good. I can really trust the identity that's at the other end of that connection. By contrast, I might have a 15-year-old printer plugged into a 15-year-old switch, and the switch is only capable of SNMP. So, but minimally, that switch can probably send an SNMP, port up trap to a management system of some sort and say, hey, a port just came up, and here's the MAC address that's attached to that. That's better than nothing. If that's all you can get, use that, and then further on in the process, we'll say, okay, well, that's going to go on the printer VLAN, or it's going to get firewall rules that say you can only do printing things. You can talk to a print server, and that's all you can do. And further, if you do something that's not that, I'm going to flag that. That's a potential security event that I can use from a detection standpoint.
And once you see, you see the device and so on. How do you then enforce that trust? And I'm assuming it has to be dynamically done because, again, things can change on the fly depending on the environment, depending on the new devices getting in, and people don't realize how dynamic networks are. It's not about setting and forgetting it. I mean, there's I think there's what's the percentage of new devices versus old devices on the network? It's got to be significant over time.
I couldn't tell you. I know at universities it's pretty high, especially when classes start and everybody shows up on campus and then they come back from Christmas break with all the new toys they got for Christmas. The percentage of brand new devices is pretty high at that point. Yeah. Go ahead.
No. So how do you then apply that trust on an ongoing basis and able to kind of segment these devices depending on their profile? How do you do that?
Yeah, so we touched on this too, but it depends a lot on the capabilities of the network equipment. So we look at, if you're coming in through a switch that we make, for example, you've got one set of capabilities. If you're coming in through one of our competitors' switches, you've got different sets of capabilities. If you're coming in through Wi-Fi, that's yet a different set of capabilities. So really depends on those enforcement capabilities. But again, minimally, I can usually do VLAN-based segmentation. Now, that's a coarse method. It's not necessarily what we prefer, just because we'd rather see VLANs used for kind of segmentation of IP address space and breaking up subnet boundaries and things like that, rather than in security enforcement. But sometimes that's, again, all you have. So we've got a customer that's a big home improvement retailer, and they talk about, out in the stores, there's a new device coming in every day, and they're all business critical, right? So you can't just say no to them. What do you do with those? Do you stick them on this wild west VLAN where all the IoT devices interact with each other? Well, in some cases, those devices might be competitors of each other, and you don't want their traffic mixing or interacting out there, or you don't trust what it's doing. But likewise, stringing a new VLAN for every type of device has its own set of problems as well. So ideally, we'd like to see something a little bit more dynamic. And that's where we get into, I've been talking about firewall rules and things like that, of being able to say, all right, this is a device of this type, it's a barcode scanner, and it needs to do certain things. Let's plumb in a set of firewall policies that say this is what you're allowed to do. And that firewall enforcement happens at that edge node. So if you're using our Wi-Fi, that's the way that we try to push people towards doing it that way, and say, forget about VLANs. Switching is a little more difficult. Switches don't usually have firewall capability built in. So VLAN might be all you get. VRFs, a lot of times you have downloadable ACLs. So you could at least do something like that, to where an access controlled system will push those rules out to an edge switch and say, enforce these ACLs. You could have tunneling capability. So if you're using our stuff again, I can take a switch and I can say, on a per port or a per user basis, tunnel that traffic back to a gateway. Gateway is a device that we typically use in a Wi-Fi network, but it has that firewall enforcement out there, and you could then enforce access rights that way. So there's a lot of different choices, and it might be different depending on the type of access equipment. So you might say, I've got a user and it's a wired user, and they're going to plug in over here one day, and then the next week they're going to be in a different building on campus somewhere, and it has completely different access network equipment out there. I need a consistent policy to follow them around, but how that policy is instantiated might be different. And that's where having a AAA system that kind of understands this identity, authentication, authorization, and then enforcement. And then enforcement, those things all need to be separate blocks from each other, and they flow together. But when you get to that enforcement point, you need to understand, what am I talking to out there, and what are its capabilities? Do I have to send an SNMP trap to say change VLAN? Again, it could be 15 years old, and that's all it can support.
Yeah, and I'm assuming that you have, because you've done it so many times, you have like best practices to deploy this, and depending on the use cases, you come back with different options and so on. Now, cloud adoption and cloud applications have really changed, what the zero trust look like. What does that mean to you, and how do companies kind of approach that today from a cloud and cloud application perspective?
Zero trust fits in really well with cloud applications, just because that's kind of in some ways, it's the reason it got started. But again, think about Office 365. I don't trust the network because the network is the internet. And so having a zero trust approach is actually really critical for cloud applications. And so I think in general, you're going to have kind of a zero trust approach in general for doing that. The question then becomes, okay, we talked about this before. What does zero trust not solve for? It doesn't solve for things like firewall, IDS, IPS, data leakage prevention, API gateways, all these sorts of different services, some of which require that you be in line with the traffic and be able to decrypt it and do TLS inspection, for example. So the kind of traditional way, people used to do this is they'd build the security stack in their data center, and they would bring all the traffic back to the data center. And so that was sort of very traditional because it assumed, an on-campus experience. I'm on campus all the time. I'm connected to an enterprise network. And so I've got this security stack, and it might be, a Palo Alto firewall and a bunch of services running on that and this sort of thing. Today, because of things like cloud applications and because of things like mobility, and we've certainly experienced this in the last year, given the pandemic and a lot of people working from home, does that model still make sense to bring my traffic back to a corporate data center? I still have to have that corporate data center probably. I've probably got an on-campus security stack for everything going in and out of that network. But what about branch offices where I don't want to deploy kind of that full security stack? The model in the past was, MPLS circuit out to a branch office and backhaul the traffic back to the corporate data center, put it through my security infrastructure, whatever that is, and then let it get out to the internet, and it can go on its way to these cloud applications. That's more complicated today because from an efficiency standpoint, that's a hairpin type of traffic approach. It's coming in from outside and then it's going right back out again. It's more efficient if I can say a branch office can communicate directly with a cloud service. I want to let users talk directly to Office 365 from a branch office. And instead of an MPLS circuit, I'm just going to bring in broadband internet to those branch offices. This is starting to get into kind of the SD-WAN or software-defined WAN space. So a new model has sprung up for providing security beyond kind of the zero trust world. And some people refer to that as SASE. That was a Gartner term. There's vendors in that space like Zscaler and Netscope and Cloudflare and others. And what they're saying is, we're going to build the security inspection and enforcement capability in the cloud. And so instead of backhauling your traffic to an on-premise box in a data center, just let it flow directly to the public internet and have it pass through our points of presence in our data centers before it goes on to whatever the ultimate service is. So that's kind of a different way to do it now. It starts to make a lot of sense when it comes to these branch offices and distributed enterprises and particularly teleworkers, in a work from home situation.
And, speaking of teleworkers, I mean, let's touch a bit about the kind of the move into a hybrid model where people are going to spend time at the office, going to spend time at work, and there's several challenges that relate to that. One is to provide the same security controls that you would provide at the office. Secondly, because people expect the same type of service like reliability when they're working from home. So, for example, you're on a Zoom call, WebEx call, whatever, and then all of a sudden the network becomes degraded and connectivity is an issue. And then on top of that, you added contact tracing, right? So you're able to potentially look at where people are at the office. So how does Aruba solve all those challenges specifically for mobile workers that are here to stay, and then have them, kind of a hybrid model where they expect the same type of services and security at home as well as the office?
Yeah, we'll solve for a subset of those problems. We are primarily, our lane out there is to be a networking vendor, and so we're providing, campus networks. We're providing SD-WAN, especially with our new acquisition of Silver Peak. We're providing branch office networks. We're doing wired and wireless. We're not so much touching people at home. Now that depends on kind of what the architecture looks like. I have sitting behind me on the shelf a device called a remote access point, and that's think about it like a wired and a wireless access point with a hardware VPN client built into it, and that actually connects me back to my corporate data center out in California. So by me connecting to that Wi-Fi network that shows up in my house, it's the same Wi-Fi network that I would see if I went to our headquarters in California. And we have people all over the world that are using that. And that is that's not the SASE approach, right? That's saying, I'm going to bring everything back to headquarters. I need to, because we're not entirely a cloud organization. We use a significant amount of cloud services. I mean, we use Office 365, we use Workday, we use Concur for travel and expense and things like that. But there's a ton of stuff that still happens inside our own data centers around HPE. And so I either need to be connected to VPN or I need to be on a corporate network. And that wrap gives me one way to do that. The second way to do that is traditional VPN, where I need to get back into a corporate environment. There are newer approaches to VPN out there. Some people refer to it as ZTNA, Zero Trust Network Architecture, which is or network access, which is sort of further confusing the zero trust issue, if you ask me. But think about it as an analog to the old school SSL VPN, where on a per application or per service basis, I'm going to have this TLS tunnel nailed up and send all my traffic through that. That works for some environments. It doesn't work in Aruba's world. I need to be able to use network tools, and I got to be able to ping things, and I've got to be able to SSH around to lots of different services. And so traditional VPN, people beat on it a little bit, but it's still very useful for that sort of thing, where I need my system here to be connected to that network full time. So it's not all one or the other in our case, and I think that's true for a lot of our customers. Now, if I'm just accessing cloud services, if I just need to go to Starbucks or the airport or something and hit up Office 365, I don't need to touch the corporate network. There's no reason for me to be VPN'd back in to do something like that. I just go direct to cloud, and the company has started working with one of these SASE providers, a secure web gateway type thing, and so in some cases we'll bring their traffic to one of those types of gateways for some type of enforcement. In some cases, we just say let it go through. There's no reason to inspect this sort of traffic. So it's very much a hybrid world.
Yeah, and talk to me a bit about the contact tracing and kind of the new protocols are coming to Wi-Fi. It's an ever-changing type of environment, right? So there are kind of new standards coming up, right? And you always keep up on that. And then what those standards apply now. What do they provide extra from what we don't have today?
Yeah, Wi-Fi access points are, number one, useful for more than just network transport. And number two, are in many ways becoming what we would call multi-RAN. Radio access network is what RAN stands for. So a couple things. Wi-Fi has long given us the ability to do location tracking, to figure out where is somebody with varying degrees of accuracy. So Wi-Fi itself, with technologies like triangulation or trilateration, can give you a certain amount of accuracy of, here, this device is over here in the building. If I have placed my access points on a floor plan, and I can figure out what's the relative signal strength between that a client is seeing. More recently, we came out with Bluetooth low energy tags and integrated Bluetooth low energy radios into the Wi-Fi access point, and that participates in a more accurate system. Because those Bluetooth transmitters are very low power. And so in order to pick them up, you have to be close to them. And the closer you are, the more accurate you can get that location information. So that provides some of the building blocks. We've then integrated things like Zigbee radios into the Wi-Fi access points. So through one network connection, that's one box that you hang on the ceiling, you now have at least 3 radios, potentially 4. And now we can start talking to different types of IoT devices. So you've got things like occupancy sensors that are based on Zigbee. You don't have to run a separate network to get access to those. You can just leverage the Wi-Fi network. It's not really the Wi-Fi, it's just the Wi-Fi access point that is providing that to hook those things up. So those are just sources of data, right? I can say these 2 MAC addresses or these 2 users, if I've got authenticated user information, are in the building. Here's where they're located right now. And if they're close to each other for a certain period of time, well, that's contact tracing, and we can record that and say, if we may not know who these users are, but we at least know that this identifier and this identifier were close to each other for a period of 30 minutes yesterday in this conference room over here. Then we can feed that to external systems that can kind of build that contact tracing information. So there's a lot of companies that are interested in that and saying, I want people back in the office, but we need to provide some safety protocols there where if somebody does get, a positive COVID test, for example, can we trace back and see who that person was in contact with so we can then notify them? Privacy problems with that, right? So there are external services that'll do this and we can feed that data to them. Do we want to feed the actual identity to them, or do we want to obfuscate that? And in different companies have different perspectives on that. Some want to say, keep that data all anonymized, and only in the event of a positive test do I need to map that identifier back to an actual name of a person. And typically an HR department would be the entity doing something like that. So that gets into an example of just, we've got a Wi-Fi network deployed, we've got radios all over the place. What else can we do with that besides just hooking up your laptop so that you can download email? That type of occupancy sensor, contact tracing, building utilization, room utilization, these are all sort of metadata that we can collect about the usage of the network as a side effect of having that network in there.
And it's super interesting that you leverage existing technologies and add them on top of the stack of what you already have, so to utilize the access points. So I'm assuming it kind of brings me to the next question is, I'm assuming that most organizations that deploy you already have some wireless network already in place. What does that look like for this organization? What triggers them specifically to say, okay, we need Aruba. These are the top, 2 reasons why. And what does the deployment or the first phase of deployment look like for them, for most organizations?
Yeah, a lot of people do have some type of wireless in place right now. It really depends on what their IT refresh cycle looks like on that. The place where I don't find it, so I do a lot of federal government work. I'm talking to you from outside Washington, D.C., so I do a lot of federal government work. And in those environments, often you don't find Wi-Fi. That's sort of the last place where you don't find these things out there. They still have this trust of wired networks, but that's changing quickly. You're finding Wi-Fi in some unusual and places that you wouldn't expect in terms of the high security environments that we go into now. So, we call those greenfield deployments where there's never been anything there before. Those customers just kind of say, okay, we have a business justification for why we need this technology, which is easy to build these days. We're going to go get the latest and greatest that's out there. People that already have it, typically it's a speed upgrade that they're looking for. Sometimes it's an additional capabilities like having Bluetooth built in or adding Zigbee or one of these newer capabilities. But very often it's simply a matter of the greater speed and the greater efficiency you can get. In a lot of our customers today, the Wi-Fi is the primary network. That wasn't true 10 years ago. Usually it was a wired network was primary and Wi-Fi was sort of a convenience network. Today, Wi-Fi is often the mission critical network, and the wired is kind of there for backup and for the things that don't have Wi-Fi interfaces. So universities are a great example. Our poor customers there don't get maintenance windows. They're told you have to keep the Wi-Fi network up 24/7 all the time, because somebody will complain. Even if it's 3 a.m, there's going to be unhappy people if they do maintenance windows. So we had to go and innovate, ways to do hitless upgrades of software. For example, we can basically say, network, go update your software version. It's going to take 8 hours to get it done, but the administrator doesn't have to sort of know what's going on there. It will automatically kind of partition the network into different partitions, update only pieces of them at a time, and then bring everything back up on the same version. And that was specifically for those types of university customers that said we can't have maintenance windows. In those environments, the efficiency of that network is kind of a big driver. And as we come out with newer generations of Wi-Fi technology, 802.11ac going to 802.11ax, which is now called Wi-Fi 6, you don't necessarily get faster speed from the access point to one individual user, but you can have multiple users at the same time, all consuming that bandwidth. And so the overall aggregate throughput that you get out of one access point goes up. And that's been a driver for people to update as well. Universities also, in particular, will use their Wi-Fi speed as a recruiting tool. They'll advertise, we have the latest and greatest Wi-Fi. It's only, it's the latest generation. Come to our campus and you can have these massive speeds. So there's all kinds of reasons, but beyond that, it's traditional IT refresh cycle. It's saying this stuff has lived its life. It's 5 years old. We replace after 5 years or 7 years or whatever it is. And usually there's a big upgrade when you do that in terms of capabilities that you get out of it.
Yeah, and it's pretty amazing that I guess the students assume that the latest and the greatest from Wi-Fi. It's something that would, bring them back to campus or have them stay. So specifically, it all boils down to in dollar and cents sometimes, right? How in your experience do companies justify the expense or define ROI specifically for something like this, upgrading to the latest and greatest and now providing those additional services? What does the ROI calculator look like for most organizations?
Yeah, we've published some out there that people will pick up, just Excel tools and web-based tools that will help do some of that. Notably, maybe 10 years ago, we talked about going sort of wireless primary. And back then, the standard was, if you had a cubicle, you'd have 4 Cat5 jacks in that cubicle, all hooked up to a switch on the other side and plug in, you've got a printer there, you've got a voice over IP phone, you've got a desktop computer or a laptop, and you plug in, there's 3 that you're using. We talked about network right sizing at that point and saying, what if instead of 4 ports per work location, you only had 1 and everything else was Wi-Fi as a primary? What would that do to your costs? Wi-Fi being a shared medium, you don't need a bunch of dedicated equipment to do that. And so that allowed people to basically cut the number of switches in their closet in half or less, cancel the maintenance contracts and the switches they didn't need anymore, not have so much power and cooling capacity required to power that equipment, and so on. And we had customers, one of the California University system locations was able to say, based on savings alone from decommissioning parts of the wired network that we don't really need anymore, we can pay for the entire Wi-Fi network that was going in. So that's one way to look at it. And that's really going from a primary wired to a primary wireless. To upgrade from a previous wireless standard to something newer, I don't know that you're going to be able to make an ROI calculation on that. I mean, you already have wireless, right? And you're just getting faster and better wireless and being able to support more services. It ends up being a quality of service or a customer support type thing where you've got people saying, I've got higher bandwidth applications today. I've got machine learning. I've got visualization. I've got video all over the place. And the current generation network technology can't support it without, students are seeing video that's buffering and jittery and things like that. We just need more bandwidth. And so that's often how those calculations are made.
That, and I'm assuming also the security controls associated with, a better network overall, right? Is applying zero trust to the network and applying the segmentation as we discussed. Jon, it's been a really great conversation. How do people, keep on having that conversation with you? What's the best way to reach you?
So Aruba has a community out there called the Airheads community. And that the name comes from when we were a Wi-Fi company only. We should probably update that at some point, but the name is stuck and people like it because we sell an awful lot of wired switches these days. That's the best place to find me and other people that are in the same space. And there's lots of conversations happening out there. So it's community.arubanetworks.com is the website. And I'm out there and a bunch of people are out there, and we can talk about whatever.
Fantastic. Thank you very much. I'm hoping that, I'll be able to maybe do this event live in New York City sometime soon. We're getting close. I can feel it in the air. People are very positive, and as I am. And, it's going to be great. You make the trip out there, take the Acela to, from Washington to New York, and it's going to be great. So thank you again for joining. Thanks all for joining today, and looking forward to seeing you at the next event.
Thank you.
Take care all.